Here's the next part of our derivatives note. So I'm going to go through and give you a couple of functions, and then we're going to find the derivative of each using the first principles. So we're going to start this off, and if you feel comfortable without writing this line, you can go ahead and do that. I am just writing it so that everyone knows where I'm coming from and what I'm doing. So the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So I'm going to go ahead and wherever I see an x, in my function, I'm going to replace it with an x plus h. So I have 1 over x plus h plus 2, subtract my original function, 1 over x plus 2, all divided by h. So in order to continue to solve this, we do need to do a little bit of algebra. I can't subtract these fractions in my numerator without a common denominator, so I am going to multiply both of these by x plus h plus 2. Now remember, if I do it to the top, I have to do it to the bottom, and then I'm going to do the same thing with this one, but this one I'm going to be multiplying through by the x plus 2. So on my next line, I have the limit as h approaches 0 of x plus 2 subtract. Now I can't forget that I'm subtracting all of this, so I do need to keep it in brackets. X plus h plus 2 divided by my new denominator, which is x plus h plus 2 times x plus 2. And then instead of writing a divided by h like this, I am just going to write it like this. I think that a lot of students do prefer it to look like this, in this line especially. Alright, so I have the limit as h approaches 0 of, and we need to remember that this negative sign needs to distribute into this entire bracket. Again, I'm going to show this line, but it's not necessary. I just want to show everyone all of my work. X plus 2 minus x minus h minus 2 divided by x plus h plus 2 times x plus 2. And then instead of a divided by h over 1, we know that if we're dividing by a fraction, we can multiply by the reciprocal, so times 1 over h. And at this point, I can now start canceling out or simplifying. So plus 2 and minus 2, x and minus x. So what I'm going to be left with here is the limit as h approaches 0 of negative h over x plus h plus 2 times x plus 2 times 1 over h. And then again, I could see that these are canceling out, and I'm left with the limit as h approaches 0 of negative 1 over x plus h plus 2 times x plus 2. At this point, I am able to substitute in my h of 0, and it will work. So I'm not going to rewrite the limit anymore, and I'm going to be left with a negative 1 over x plus 0 plus 2 times x plus 2, and I do prefer this, negative 1 over x plus 2 squared. And there's our derivative. All right, we've got our next example here. My function is the root of x. So f prime of x is equal to the limit as h approaches 0. I'm going to skip writing the formula here and go right in. So I have the square root of x plus h minus my original function, which is the square root of x, all divided by h. Now at this point, it should look familiar to you. Most of you will know that if we need to solve something that looks like this, we will have to rationalize. So we are going to be multiplying by the square root of x plus h plus the square root of x. And again, if we do it to the top, we have to do it to the bottom. All right. So the limit as h approaches 0 of, now we know that if we were to FOIL this out, we would be able to simplify. So I am going to skip this line as well and just jump right to the answer here. So I have x plus h minus x. So again, I would have root x plus h times root x plus h. That just leaves me with x plus h. I'd have a root x plus h times a positive root x, and a root x plus h times a negative root x, so those are canceling out, and then a root x times a root x, so that's why I'm left with my subtract x. Divided by, everything on the bottom needs to stay on the bottom, so x times the square root of x plus h plus root x. The limit as h approaches 0 of the x and the minus x are canceling out, and then I'm also going to have this h and h that are going to cancel out as well. So I'm going to be left with 1 over the square root of x plus h plus root x. At this point, I am able to substitute h equals 0 in and remove that limit, and so I am left with 1 over the square root of x plus the square root of x, or 1 over 2 root x as my derivative. Okay, so our third example, f of x is equal to x times 6 minus x. I hope that you can look at that and recognize that this is a quadratic. We could easily find the roots since it's in factored form. And we should be able to tell that it is opening down because we are going to have a negative x squared. I'm going to start by finding my derivative using first principles. So we have f prime of x is equal to the limit as h approaches 0 of f of x plus h. So we have x plus h times 6 minus bracket x plus h. This bracket is very important here. Please do not forget to add that. Minus our original f of x, so x times 6 minus x, all divided by h. I'm going to show a lot of steps here, so if you do not need to show all of these steps, that's totally up to you. What I'm going to be doing in this step is just distributing this minus sign. I did tell you that that bracket was important, and you will see why here. So 6 minus x minus h. Minus, and while I'm at it, I might just distribute these as well. 6x plus x squared all over h. The limit as x approaches 0, I am going to FOIL this guy out right here. So I have 6x minus x squared minus xh plus 6h minus xh minus h squared. I'm sorry, I'm running out of room here. Maybe I'll make it smaller. There we go. Minus 6x plus x squared, all divided by h. I can go ahead and I can cancel some of these things out. I have a 6x and a minus 6x. I have a negative x squared and a plus x squared. And I have a minus xh and another minus xh, which I will rewrite here as a minus 2xh. So the minus 2xh minus h squared plus 6h, all divided by h. Now when I moved this over, I don't know why that didn't show up. There we go. Now when I look at this, I know that I can't just substitute 0 in yet. If I do that, I'm going to be dividing by 0. That doesn't work. But if I look at my numerator, I see an h in all of these terms. So I am able to factor out that h. So h times negative 2x minus h plus 6, all divided by h. Now I'm able to cancel that out, and in this next line, I am actually able to substitute in the h of 0 and get my derivative. So when I do that, I'm left with negative 2x plus 6. All right, so I am adding a part B and a part C to this question. So for part B, I'm asking you to graph the function and its derivative. So what I've done here is I've just rewritten the information because it was on the previous page. So I rewrote our function x times 6 minus x, and I rewrote our derivative that we found, negative 2x plus 6. So before we can graph, I do want to go through a couple of things. Because this is in factored form, we do know a lot, or basically all of this information already. We can easily find our roots or our zeros. So we know that we have one of them at 0, and we know that we have the other one at 6. We know that this is going to open down. Now, I know that it's opening down because, again, if I distribute this x, I would have this minus x squared. And we also know that we can find the vertex. So if we have a root at 0 and a root at 6, we know that our vertex is going to have an x value of 3. And if I plug that x value of 3 in wherever I see an x here, I'm going to get 3 times 6 minus 3, which is 3, so my vertex is going to be at 3, 9. So because I need to find a new grid, because this one's so tiny, I had to make my x-axes and y-axes different, and I don't really love that, but that's okay. I have some zeros at 0 and 6, so I guess this is even worse than I thought it would be. I've got 1 here and I've got 1 out of my graph, and I don't like that. I know that my vertex is at 3, 9, so I'm just going to put this axis of symmetry in here. So 3, 9 is going to be right here, and I know that this parabola opens down, so all of this makes sense, and I can get my sketch in right there. Now when I look at the derivative function, I know that it's linear. It is y equals mx plus b, so I have my slope is negative 2 and my y-intercept is 6, so 2, 4, 6. I can use my rise over run, so down 2 over 1, down 2 over 1. Again, remember this y-axis is going up by 2's, which is why it looks like I'm only going down 1. Either way, I have this linear function for my derivative. I am doing this because it is important to recognize a couple of things. Our original function was a quadratic, or a power of 2, and our derivative is linear, or a power of 1. So our derivative is 1 less than our original function. Knowing what's happening is going to be critical in the next couple of chapters, and so I just thought it would be nice to show you visually what's going on. All right, so part C, determine the equation of the tangent at the point 1, 5. Now, we already figured out the derivative, so we know the equation of the tangent line. We just need to figure out that equation at the point 1, 5. So here I have m equals negative 2x plus 6. That was just my derivative. I'm going to go ahead and I'm going to plug in this x value of 1 to figure out what the equation is at that point. M equals negative 2 times 1 plus 6, m equals 4. So I know that I have y equals 4x plus b. I'm going to take this 1, 5, and I'm going to plug it in, and I'm going to be able to solve for my y-intercept. So 5 equals 4 plus b, b is equal to 1. I have my m, I have my b, and I could write my final equation. So therefore, the equation of the tangent at 1, 5 is y equals 4x plus 1.